Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Hi, calculate in kilojoules per mole of energy necessary to completely remove an electron from the first shell of hydrogen atom. R is equal to 1.097 times 10 to the negative 8 meter per nanometer. Okay, so nanometer to the negative 1. Now, want to know about that one? Be careful with this one. Now we're going to get started. We still use a Baumol equation, the R equation. So we have R here. Okay, now we're going to continue to solve it. Now it is actually coming from 1. I need to change the color. All right, so 1 square. Now since we're losing it, this part is basically essentials, the infinity, because your electrons are very, very far away from nucleus. Okay, so this whole thing essentially is just going to be 1 basically, right? Because 1 over infinity square is going to be zeros. 1 minus 0 is just basically 1. So that means 1 over lambda is equal to this. To solve for the lambda, okay, lambda, we're going to have 1 divided by 1.097 times 10 to the negative 2 nanometer, inverse of course. Now to solve for that, we need to flip-flop that nanometer inverse. So nanometer inverse, when you solve for this, we're going to get nanometer. This whole thing is going to become nanometer. So you can just kind of write it as this nanometer. Um, so again, divided by the inverse is essentially the same thing as over above. So I'm just going to write it up there just to not confuse um, changing the unit, which is what we're going to do now. Because to solve for energy, I don't know if you remember the equations, energy equation do require us to use in a meter because this is joule per second, this is meter per second. So that means I do need a meter. So I need to go back there and solve for meter. Okay. So again, 1 nanometer is 10 to the negative 9 meter. Now again, if you prefer to write the other way around, it will be 10 to the 9 here and then 1 here. Same idea. Okay, so let's solve. 10 to the negative 9, we're going to have divided by 1097. All right, see, so we're going to get this at 9.1 pen decimal. It's a little hard to show up here. I think we're at the edge of the computer screen, whiteboard. Anyway, this is what you have. And I now solve for this. So we're going to plug it into here. 9.1 times 10 to the negative 8. If you can save the number from the previous, save the number so that you don't get yourself confused. Okay. 6.626 times 10 to the negative 34. Okay, time 3 times 10 to the 8, which is going to divide it by the previous number. We're going to get this at 2.18 times 10 to the negative 18. Notice the unit. This is joules. In this case, it is joules per photons. All right. So let's go back and take a look at our question. Our question says kilojoule per mole. So let's go back. Let me add a new screen. So I want to rewrite that earlier number, 2.18 times 10 to the negative 18. This is joule per photons. So to change it, we're going to have to change this by kilojoules. So 1 kilojoules, 1,000 joules. Photon, famous number, Avogadro number, 1 mole, 6.022 times 10 to the 23rd photon. Okay, so that's what we're gonna get. So we're gonna solve this. Multiply. I'm gonna need to divide it by 1,000. to keep that check, we're gonna get 1313, the unit kilojoules per mole. That would be the answer. All right, happy learning.